Welcome back to part 2 on logarithmic and exponential equations. In this video, we're going to look at the logarithmic equations. To solve a logarithmic equation, use the law of logarithms and create a single log isolated on one side, then change to an exponential form and go from there. You could also exponentiate both sides of the logarithm, which is similar to what you have seen in the previous video where you impose a logarithm on both sides. So if you have a log, you impose an exponent. If you have an exponential equation, you impose a logarithm. Let's take a look at example 2. We have the natural log of x minus 3 is equal to 2. You could do this two different ways. You could say that the common log, base e, of x minus 3 is equal to 2, and you could take e raised to the 2 equals x minus 3. So you would have e to the 2 equals x minus 3, and then you would add 3 to both sides, and you get e to the second plus 3 equals x. And you could find the actual value. This is the exact value, or you can approximate it with your calculator. The other way you could do this is to just say, well, the natural log is the common log with base e, so I'll just say e to the 2 equals x minus 3. So all the way back to that thing I called the log scorpion, you'd have e to the 2 equals x minus 3. So there are two ways you get the same exact thing. Now let's look at b. We have 5 plus 2 times the natural log of x equals 4. Let's isolate the natural log by subtracting 5 from both sides. That will give me 2 natural log of x equals negative 1. Now let's divide by 2 on both sides. So I get the natural log of x equals negative 1/2. I could either say e raised to the negative 1/2 equals x, or I could exponentiate both sides and just say x equals e to the negative 1/2. You get the same exact answer. So we'll say e to the negative 1/2 equals x. Next example. We have 2 times log of 3x equals 4. I'll divide both sides by 2. Now I'll have log of 3x equals 2. I know that this is base 10, so I'll take 10 raised to the 2 equals 3x. Well, 10 raised to the 2 is, or the second, equals 100, and 3x can be divided by 3 to isolate the x, and we get x is equal to 100 divided by 3, and that doesn't reduce. So that's an exact number. I know it's an improper fraction. If you wanted to divide it, it'd be 33.3333 repeating, and that's not necessary. Let's look at the next example. We have log base 10 of x minus log base 10 of x minus 1 equals 1. Remember, when you have two logarithms and their bases match, you can rewrite this as a fraction with one logarithm. X is in the numerator since it's the positive term, and x minus 1 is in the denominator because it is the negative term. We know that equals 1. Therefore, we can take the base, which we know is 10 because it's not written there, so we know it's 10. 10 to the 1 equals the fraction, x over x minus 1. So let's rewrite it that way. 10 to the 1 equals x over x minus 1. So 10 is equal to x over x minus 1. We're almost there. Multiplying by x minus 1 to clear my fractions on both sides, I get, distributing the 10 through, I'll have 10x minus 10 equals x. Notice that the x minus 1 in the denominator divides with the x minus 1 in the numerator on the right-hand side. Now, I can subtract x from both sides, and I can add 10 to both sides. And I get 9x equals 10. So if I divide both sides by 9, I'm going to get x is equal to 10 divided by 9. And that's my answer. Again, an improper fraction, but exact. And I like exact answers. Those are usually acceptable answers at this level in a math class. Our last example is log base 3 of 4x minus 5 equals 3. I'll use the log scorpion. 3 raised to the third equals the stuff inside, 4x minus 5. Then I'll calculate this 3 to the third, that's 27, equals 4x minus 5. Next I'll add 5 to both sides, and I get 27 plus 5, which is 32, equals 4x. Next I'll divide both sides by 4, so I'll have 32 equals 4x, divide by 4, divide by 4. Therefore, x is equal to 8. So that is how you solve logarithmic equations. You can either exponentiate or use the log scorpion. Either one works.